Good morning, my dear students. Welcome to the discussion on the subject Engineering Graphics. Under Engineering Graphics, we are going to discuss a topic on development of surfaces. Under development of surfaces, we are going to discuss a solved problem on parallel line method. This is the fifth solved problem we are discussing under parallel line method under the topic of development of surfaces. Now we will enter into the problem. This problem is very important and it was asked many times under university examinations. In earlier videos, we have discussed the problems of development of surfaces based on theoretical information, whereas in the present problem, in addition to theory information, even figure also supplied in the problem. Now I will read out the problem.
The given problem is, the figure shows the front view of the truncated hexagonal prism of base side 30 mm and axis 90 mm. The prism is resting on its base on the HP with an edge of the base parallel to the VP. Draw the development of its lateral surface. This figure shows the front view of a truncated hexagonal prism of base side 30 mm and axis height 90 mm when the hexagonal prism is resting on its base on HP so that one of its base side is parallel to the VP. This hexagonal prism is cut by three section planes. Those three section planes are perpendicular to the vertical plane. Here, this is the first section plane which is making an angle 60 degrees to the HP and passing through the topmost point of the axis in front view. And the second section plane is making an angle 45 degrees to the HP and passing through the topmost point of the axis in front view. And this is the third section plane. After cutting the hexagonal prism with three section planes, part P portion of the hexagonal prism is left over. Here, our objective is to develop the lateral surface of the part P portion of a hexagonal prism. After cutting the hexagonal prism with the first section plane, then this portion of the hexagonal prism's material is removed. Then, after cutting the hexagonal prism with the second section plane, then this portion of the hexagonal prism's material is removed. After cutting the hexagonal prism with the third section plane, the material below the section plane is removed. Again I am saying, here our objective is we need to develop the lateral surface of part P portion of a hexagonal prism. For that, we are going to use parallel line method and it is also called stretch out line method. Now we are going to write the data related to the given problem. The name of the object is hexagonal prism and it is resting on its base on HP such that one of its base sides say BC is parallel to VP and its base side length is 30 mm, axis height is 90 mm. Say B dash C dash, that is length of the base side, say BC in front view, which is nothing but B dash C dash length is equal to 30 mm. Here the base side is parallel to the XY line, so B dash C dash is also parallel to the XY line. For the development of the lateral surface of the truncated hexagonal prism, the following three steps are followed. The first step is to draw top view as well as front view of the hexagonal prism. Second step is drawing section plane lines in the front view with the given conditions. Third step is to draw lateral surface of the truncated hexagonal prism. Now we will move towards the first step, that is drawing top view as well as front view of the hexagonal prism. For that, first we will draw XY line. After drawing XY line, then what we have to do? As we know that in the case of projection of solids, first we need to start the projection of the true shape of the base of a solid. Here, the true shape of the base of a solid is visible only in the top view. The true shape of the base of a solid is a regular hexagon, and also the base side of the hexagonal prism, say BC, is parallel to the vertical plane. So while drawing the true shape of the base of a hexagonal prism, that is regular hexagon, see that its side, say BC, is parallel to the XY line. So construct the regular hexagon on horizontal plane so that its side, say BC, is parallel to the XY line. Here the base side length of the hexagonal prism is 30 mm. So with 30 mm as a base side length, construct the regular hexagon. Here this BC side is parallel to the XY line. For construction of the hexagon, we are using circular method. This is the top view of a hexagonal prism when it is resting on its base on HP, so that one of its base sides, say BC, is parallel to VP. Here A, B, C, D, E, F are the bottom base corners, and A1, B1, C1, D1, E1 and F1 are the top base corners of a hexagonal prism. O and O1 is the image of the axis in top view. With this we completed drawing top view of the hexagonal prism. Then we will move towards drawing front view of the hexagonal prism. For that, draw projectors through the points, say A1, B1, C1, D1, E1, F1 and O1 towards the vertical plane. For that, first we will draw projector through the image of the axis point in top view towards the vertical plane. Here, the top view as well as front view lines are drawn with 3H pencil, that is thin lines. Here, the height of the axis given in the problem as 90 mm. Then name this point as O dash and this one as O. After that, draw projectors through the points, say A1, B1, C1, D1, E1 and F1 towards the line drawn parallel to the XY line, passing through the O dash point. Because the hexagonal prism is resting on its base on HP, that's why this A dash D dash line falls on the XY line. Here A1 dash D1 dash line is nothing but image of the top base of a hexagonal prism in front view, whereas A dash A1 dash B dash B1 dash C dash C1 dash D dash D1 dash are nothing but images of the face edges of a hexagonal prism in front view. With this we completed drawing top view as well as front view of the hexagonal prism when it is resting on its base on HP and axis parallel to VP, and one of its base side is parallel to the vertical plane. Then we will move towards the second step. that is drawing section plane lines in the front view. Here the first section plane is making an angle 60 degrees to the HP and passing through the topmost point of the axis in front view. First we will draw first section plane. Second section plane is making an angle 45 degrees to the HP. So then draw second section plane. Then third section plane need to be drawn. The radius of the third section plane is 25 mm and the center of it is O. With O dash as a center, 25 mm as a radius, draw an arc. After that, dark this region. Drawing section plane lines in front view is completed. Then we will move towards locating the intersection points of the section plane lines with the face edges as well as base edges of a hexagonal prism in front view. Here 1 dash is the intersection point of first section plane with the face edge A dash of a hexagonal prism. 2 dash is the intersection point of first section plane with the face edge of the hexagonal prism, say B dash B1 dash. 3 dash is the intersection point of the first section plane with the base edge image in front view, say B1 dash as well as C1 dash. Then 4 dash is the intersection point of second section plane with the face edge of the hexagonal prism, say C1 dash. 5 dash is the intersection point of second section plane with the face edge of the hexagonal prism, say D dash D1 dash. Similarly, we will get 6 dash, which is the intersection point of second section plane with the face edge of the hexagonal prism, say E dash and E1 dash. 7 dash is the intersection point of base edge of the hexagonal prism, say E1 dash and F1 dash with the section planes. 8 dash is the intersection point of first section plane with the face edge of the hexagonal prism, say F dash as well as F1 dash. After that, locate the intersection points of the third section plane with the base edges as well as face edges of a hexagonal prism in front view. For our convenient purpose, we are taking 2 more extra points on the semicircle in the front view. Say this is P dash, this is Q dash, R dash, S dash, T dash, U dash, V dash. That is, for our convenient purpose, we have taken extra 2 points on the semicircle in the front view. Then draw projectors through P dash, Q dash, U dash, V dash towards the top view base edges of a hexagonal prism. location of intersection points of the section plane lines with the face edges as well as base edges of a hexagonal prism is completed, then we will move towards drawing the development of the lateral surface of a hexagonal prism. For that, we are going to use parallel line method, or it is also called stretch out line method. For that, draw two stretch out lines in line with A dash D dash line and A1 dash D1 dash line. These two stretch out lines are parallel to each other with a gap of the axis height of the hexagonal prism, which is equal to 90 mm. Then locate a point A on the bottom stretch out line. Then with A as a center, base side length say 30 mm as a radius, draw an arc on the bottom stretch out line. Then name this point as B, with B as a center with the same radius, draw an arc. Then name this point as E, E as a center, C, with C as a center with the same radius, draw an arc. Say D, D as a center with the same radius, draw an arc. Then name this point as E, E as a center with the same radius, draw an arc. Then name this point as F, F as a center with the same radius, draw an arc. Then name this point as A. Then draw perpendiculars to the bottom stretch out line, passing through the points say A, B, C, D, E, F and A towards the top stretch out line. Here P and Q are the points on AB bottom base edge and A1 F1 top base edge. So transfer these points from the top view to the development base edges. For that, take BP as radius, B as center, draw an arc. Similarly, BQ as radius, B as center, draw an arc. Similarly, CU and CV also with the same radius, and these 2 points are on the CD base edge. Similarly, 3 and 7 points are also transferred onto the development. B3 as radius, B as center, draw an arc. Then F7 as a radius, F as a center, draw an arc. Then name this point as 3 and this point as 7. After that, draw horizontals through the intersection points of the section planes as well as base and face edges of a hexagonal prism in front view towards the right hand side direction. Now name the intersection points in the development. Here this is the 1, this is 2, this one is 3, 4, 5, 6, 7, 8, 1. Then join the points, say A to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 7, 7 to 8, 8 to 1, 1 to A with continuous dark lines, that's to with H pencil. After that, name the intersection points of the semicircular section plane with the hexagonal prism. Say P, Q, R, S, T, U, V, V, U, T, S, R, Q, P. Make a note. These points are joined with freehand curve with the H pencil. That is, this curve to be darker. Then dart the part of the hexagonal prism face edges, say R to 2, T to 4, D to 5, T to 6, R to 8 with H pencil. That is, we need to draw dark lines. This is the required development of the truncated hexagonal prism with 3 section planes. Now we will see the pencil usage details. The blue color lines in the top view as well as front view and also in the development are with H pencil, whereas pencil marks are with 3H pencil, dimensioning is with 2H pencil. Related to the dimensioning details, the base side length of the hexagonal prism is 30 mm, axis height is 90 mm and the perimeter of the hexagonal prism's base is 180 mm. That is, all dimensions are in millimeters. Make a note, my dear students, this is very important problem and also it was asked many times under university examinations. This is the required development of the lateral surface of a truncated hexagonal prism.
If you have any queries or doubts related to the present solved problem, you can mention it under comment section of this video. I'm happy to answer it as quickly as possible. For more videos on engineering graphics, visit the links provided under description of this video. Keep learning on knowledge sharing. Stay blessed. Thank you.